hello everyone, and welcome to today's Phoenix webinar. My name is Tsetso, and I'm part of the 3D team here in Chaos Group. And today I will be showing you a breakdown of two typical scenes for Phoenix, and this is the first scene that we'll take a look at. It's a river example, and I'll walk you through the setup of the scene in general, and then we'll take a look at adding a detail as foam and splashes. Okay, and the next scene will be this more of a commercial type of shot. It's a beer poured into a glass. And yeah, so one of the first and most important things when creating dynamics and using Phoenix, and generally it's not only Phoenix but every simulator out there, you have to set up the units and the scale of the scene. So if I open 3ds Max, that is usually done here in the customize and unit setup, and I'm presented with this window, and if I click the system unit setup, here I can set the units that Max will be using. And I always use one unit to be equal to 1 centimeter, and since we are in Europe, it's easier for us to work in centimeters, but if you work, let's say, in US, you can of course use inches and feet, and these are not, these doesn't change anything, they're just for convenience. So if you said, as I said, 1 unit is equal to 1 centimeter in most of my scenes, so I press this to OK, and I also switch the display units to centimeters as well, so that they are basically the same. And if I create a box, for example, now I know that this box is with this size. And basically the important thing here is to create geometry that that has let's say real size of as is. Basically you create the object size as it's in the real world. So if you create a ship, for example, you would want to create it big enough, let's say 150 meters, for example, if it's a big big ship, and this will ensure you that you have proper dynamics. Whereas if you create small objects, you might end up with wrong dynamics, and basically it's not a good practice. So if I switch back here, here's another example. Since I'll be creating a river, I modeled this riverbed and added some stones, and you can see that the length of this riverbed is 22 meters, and I also added the size in feet. Again, it doesn't matter what the units are. The important thing here is the size, the scale. So that's something that that we want to set up before we start simulating. And here's an example of what might be a wrong setup. So if I created the riverbed only 22 centimeters long, I'll definitely get some wrong dynamics. And even if you try to imagine having a real river in a box that's, let's say, 20 centimeters big, you can imagine that probably it will look like more like some random noise instead of actual river. Okay. So if I jump back to 3ds Max and open a scene, okay, so I have this scene here, and here is my riverbed. It's roughly about 22 meters, so that's okay. And the way I usually start this type of simulations is by adding some source from and emitter where the water will start flowing from. So I can create a separate geometry, let's say here at the top, or I can use this riverbed geometry. And what I did is I made a selection of polygons here at the top, and this is the place where the water will start flowing over the riverbed. So I selected this, made that selection, and here I set the ID for these polygons to 3. And here in the source I added the riverbed, and I also specified which polygons I want the water to start appearing from. So I set this to 3, and I've also set the mode to inject, since I want to inject the liquid, and I added a discharge of 100, which depends on the scene. If I have a bigger scene, I can increase this number, or if I have a smaller scene, I can decrease it. It's dependent on the scene. Okay, and once I have that, I can press the start button, and the water starts flowing. And that's okay, but it will take some time until that water reaches the end of the simulator, and the bottom of the riverbed. So what I can do to speed up that process is I can use another Phoenix feature, which is here in the liquids rollout, and it's called initial fill up. So if I enable this option, Phoenix will fill the entire simulator with liquid right from the beginning, and I won't need to wait for this tiny little stream to fill the entire simulator. So again, if I press start, you can see now the simulator is filled right in the beginning, and the water here starts flowing. Yeah, that's nice. But let's say if I have a riverbed that is not in this straight fashion, but it's, let's say, has some curves and something like this, I won't be able to use the initial fill up option, and instead what I can do is I can open up my layer editor and unhide this layer. So I can create a custom geometry that I'll be using to fill up this this simulator, and I will just clean the cache files so that we can see a bit better. Just pause this. Okay, and let me just show you this geometry first. If I display it as a real mesh, so I created this geometry from the riverbed geometry, and what I did next is I created another source, and here I've added this geometry and set the source to brush type, which means that I will print this volume inside the simulator right from the beginning again, and here the discharge acts as a percentage. So if I set it to 100, means that 100% of that volume will be filled with water, and you can animate this to, let's say, for 1 or 2 frames only. And here I've animated that frame 0 to be 100, and then at frame 2 it's 0. So we're just initiating this this volume in the simulator for just a frame. And another thing that you have to do also is select that geometry, and here under Phoenix FD properties you have to disable the solid object, which means that Phoenix will be able to fill the volume of that geometry instead of emitting from the surface. Okay, and I'll set it to be displayed as box again so that we can see what will be generated in Phoenix. And when I press the start button at the first frame, I get these jagged edges, but since the simulator is tilted, the water starts flowing nicely. And again, I can use my riverbed as another source here at the top and combine these two methods. Okay. So again, to recap, you can make a polygon selection and use that to emit water, let's say, or you can use the initial fill up in combination with the emission and get something like this, or you can use a custom object, use another source in brush mode to create this type of effect for, again, riverbeds that make turns and have more complex silhouette. Okay, and of course the next thing will be adding detail in this simulation, and by detail I mean splashes and foam, which is the thing that everyone is so excited about. So I'll open this scene, and the way I usually do this type of effect is I start with adding splashes. So in this case, I just set the rate to some low number so that I can have so that I don't generate too much particles and I get faster feedback. And I will press start. And you can probably already see these green dots. They are representing my splash particles, and just destroy cameras. And they're representing my splash particles. And from here on, I can start specifying the areas where the splashes will be generated. And ideally, I would want to have these splashes created only on the thinner parts of the liquid, and also where we have some churning, vorticity, and so on. So I will increase the rate a little bit to add more particles. So if I set it to 15, let's say, just to see it a little bit better, you can see that I have splashes appearing in some more smoother areas. So to control where they appear, I can just use the threshold. So if I lower the threshold, they will start to appear everywhere. And if I increase it, they will just be generated here at the thinner and more vorticity part. Okay, and for the foam, my preferred method is to generate it from the splashes. So now that I have specified the areas where the splashes are generated, I can just start adding foam there. So what I'll need to do is here in the splash route under foam on hit, I can just increase the amount to 1, let's say, and enable the foam for simulation. And you can see that the splashes start to create the foam. And of course, you can increase the amount of foam from the amount here, or you can also experiment with all the other parameters here. And by the way, this doesn't look very good now, since the water is very low res and we don't have any nice detail, so that's why we see the foam and the splashes in this making these streaks all over. So once you add more detail by increasing the resolution in our simulation, we'll have better reproduction of the foam and splashes. Okay, and that's it for the foam and splashes. So you can see here the mesh is more detailed and we get nicer foam and splash. And what we can also do to add a little bit more detail is add mist, which is a separate aerial simulation. And really quickly I'll show you how we can achieve that. So if I open up the layer editor again, I have this prepared this new simulator, which is simulating smoke. And here in the source, I can click the add button and select the simulator with the water. And I'm presented with this window here, where I can specify which element of that simulator I want to use as an emitter. So in this case, I can use the foam particles, for example, these white guys here, and just press OK. And by the way, in order to be able to pick other Phoenix simulator, you have to check this can pick Phoenix checkbox. And straight away, I can press the start button. Let me just see. I'll start the simulation from, let's say, frame 125, since here I have enough foam to generate smoke, and press start. And by the way, everything here is pretty much default for the smoke simulation. And you can see these voxels that are appeared here. They are representing the smoke and or the mist. And if I change the viewport, you can also see a GPU preview of that smoke simulation that is happening right now. Okay, so I'll stop that. And yeah, that was pretty much for the river. And as I mentioned earlier, I will show you this this scene now. So I'll open up another scene. We just okay. Okay, again, in this case, we'll start with setting up units and scale. And in the previous example, I told you that it's a good idea to make objects in real size. I mean, make them big enough so that you have proper dynamics. And in this case here, we have a glass object that is relatively small. So it's I found that glass somewhere, and I measured it. It was 20 centimeters in height. So I started simulating with this dimension, but I faced a few problems. So since the simulator box was only 20 centimeters high, the dynamics inside that simulator was very, very strong, and which supposed that I will need to increase the steps per frame so that I divide the time into more smaller parts to get a better result. So that, of course, resulted in a slower simulation. So instead of battling with this size and the higher steps per frame and so on, I just increased the size of the glass. I made it twice as big, and the only downside to this method is that you have to scale your geometry. But as a positive thing, you will be able to simulate with lower steps per frame. Again, from that, as a result, you have a faster simulation, and with, of course, you also have better dynamics. And if you need some more artistic approach to this type of simulations, you can even make the glass even bigger. and then the liquid inside that glass will be splashing as if you're watching an ocean or some very big body of water. So it's up to you how much bigger you want to create it, but in this case I stick to it, the 40 centimeters high glass, and there it is. So again, if I create the box just to measure it roughly, it's about 40 centimeters high. Okay, so in this scenario here, again, I'm using an emitter, which is this cylinder here, and I made a selection of this bottom face, and I assigned it an ID of 1, and all the other faces are different ID, and that's again specified here in the source. I set the source to emit only from polygon ID 1, and I also picked the emitter. Again, using inject, and you can see I lowered the discharge here since the scene is smaller. And now when I press start, the liquid starts flowing from the emitter and into the glass. And you can see the first issue that we are facing is that water that is spilling outside of the glass. And the actual reason for that behavior is the thickness of the glass. And the general rule that we have is that the objects that are getting filled with some sort of liquid should have a width at least 2 cells wide. So if you check this thing here, these lines are representing the size of the voxels, and our walls of the glass should be at least this much wider. So what I did next is I went here to the grid section, and under cell size I checked the cells, the size of the cells, so it's 0.31 centimeters, and I created this little box here that has the same dimensions. It's 0.31 centimeters, which basically represents 1 voxel from the simulator. So then I position this here where the thinner parts of the glass are, and if I zoom in, you can see that the walls of this glass are even thinner than 1 voxel. And as I said, I need it to be at least 2 voxels wide, so I'll make these 2 boxes as a reference of how much wider should I make the glass. And here I scaled the outer faces of the glass, so I made a selection of these faces, and I'll just scaled them out a bit. And if I take a look from this perspective again, you can see that now they are fitting inside inside the thickness that I ideally want to have. Okay, and now I should be pretty much set up. So press start again. And there we go. Now we have much better behavior. The water doesn't spill anymore. But something else that's bothering me is that the moment that the liquid touches the bottom of the glass, and a few frames later the glass is almost half filled. So that's not very realistic. So what I can do is I can open the dynamics rollout. Let me just close this thing. And here under conservation, I can increase the quality to, let's say, 40. And let's Let's press start again. So in this way, I will get more accurate results, so it won't fill up so much faster. And you can see here, so if I compare the results, here it is with the conservation of 30 and now with 40. Of course, now the water is not splashing so much, but I can, let's say, put it in the middle, 35, and start the simulation again. It's basically an artistic approach to how you want to set it up. So now it's splashing more, and it's also it also doesn't feel so much faster. Okay, and again, to recap, we started off with liquid that was spilling all over. So to fix that, we made the walls of the glass object at least 2 cells wide, so that we can keep the liquid inside. And then with the conservation quality, we changed how accurate the simulation, the preservation of the volume will be. Okay, and next thing is again adding details. So we'll start adding some foam now, and I'll open up one more scene. There it is, and here I just enabled the foam, and I also animated the rate, and I'll press start and explain why. So the reason that I animated the rate, which directly controls the number of foam particles that will be generated. Sorry, it was the reason I animated it is because I don't want to have any particles created until that point here. So when the liquid touches the bottom of the glass, then I want to start the emission. So I just animated it to start from here. And instead of waiting, I've already simulated this thing, and I'll open the scene. Okay, and we have this. So actually, sorry, it was this thing. So we have this result, and it kind of looks okay, but not really. And I also have this preview here. So as you probably notice, the foam here at the top is not enough for most of the shots that clients require. So we want to have a bigger volume up here, and to achieve that, what I can do is I can increase the size of the bubbles. Okay, so I can set this to, let's say, 0.21, and also another thing is these bubbles here at the top are actually constantly dying, so they can't preserve the volume that we want. So I can increase their lifespan. So by setting the half-life to some very large value, I'm making sure that none of these bubbles will die in my time frame here. Okay, and I'll open this scene here. So this is the result when it's simulated. Now I have this nice volume here at the top, which is okay, and I can compare it with the previous one. So we have this volume now, but what bothers me now is that these bubbles here are rising very uniformly, and they're actually rising with the same speed. And to break it up a little, what I can do is I can again select the simulator, and here under phone I can add some variation in the size. So I can set this to 2 and the variation down to 10. And what these two actually do is variation up is a multiplier of this value here. So I'll have twice as big particles as my basic ones, and I also have 10 times smaller than these guys here. And the ratio between how much bigger and smaller particles bubbles I get is controlled with this distribution here. So the bigger the value, the more smaller bubbles I'll have. Okay, and instead of simulating again, I will just open the scene where I have this thing simulated, and there we go. Now the bubbles are rising. Let me compare this with the previous two. So the bubbles now are rising not so linearly, and it's much more pleasing. And another thing that you have to predict when decreasing the, or actually when you're adding variation in the size, is that I also increase the rise speed. So usually the bigger bubbles are rising up faster and the smaller will be rising slower. So since I added so much smaller bubbles here with the distribution and the variation in the size, I've gone ahead and increased the rise speed to make sure that all of my bubbles will rise towards the top in my frame rate here of 400 frames. If I haven't changed this, I will probably need it to expand my time frame to, let's say, 600 or 800 frames, but instead I can just increase the rise speed. And again, to recap this, in order to get a nice volume here, I've increased the size of the bubbles, and I also increased the lifespan, and this resulted in this even, I mean, every bubble here is the same size and we don't have any variation, which results in all of them rising with the same speed. So I also introduced some size variation, and I increased the rise speed to force the smaller bubbles rise faster. And yeah, so once we have this simulation done, we can start rendering. And I'll jump back here to 3ds Max and say a few words about the object voxels. So if I open these things here, okay, I have two simulators, and one of the simulators is using is set to circumscribed object voxels, and the other is set to inscribed. So you just collapse this, and this one is set to inscribed. Now when you turn this checkbox on, when you turn the liquids on, Phoenix automatically switches the object voxels to inscribed. And basically with the inscribed mode you can get this this smooth result, whereas with the circumscribed you can get this this effect here. So to explain a little bit better what's happening is I'll open this images here, and let's imagine that this is our simulator, and we are looking from the top, and these little squares are our voxels. And so far we added glass, which we wanted to fill, and we also added a source to start the emission from. And we poured some liquid inside, and this is the result with the circumscribe mode. So what happens here is Phoenix checks if the cell is colliding with an object, and if it is colliding, it won't fill that cell with liquid. So you have an empty cell, and you have these air gaps that are forming here. So that's this thing here, this jagged edges. And what inscribe does is, again, Phoenix checks if a cell is colliding with geometry, and or I should say intersecting with the geometry, and if it is, it will fill this this voxel with liquid, and it will do this. Basically, this will be the result with inscribe mode. And if I jump back to 3ds Max and scrub the timeline and press render, you can see that again with circumscribed I have these jagged edges, but I also have the same thing here with the inscribe. And what's the reason for this is if we take a look at this image again, you can see that I still have these jagged edges, and to remove them I can use another Phoenix feature, which is the gizmo cutter. So I can cut all these excess parts here and make a nice smooth transition. So here in 3ds Max, if I go to rendering, just a second. Okay, so if I go to rendering, and I have this gizmo feature, so I can enable the gizmo, and here click the none button and pick the geometry that I'll use as a cutter. So I'll pick the glass, and I'll also invert the gizmo. And now when I press render, I will get this smooth result. Okay. So the next thing here is something that should be taken into account when again simulating with foam particles, and it's an effect that let me just go back to 3ds Max and open a new scene where I will demonstrate this effect. Okay, so I simulated my beer here, and I added foam, and if I click render now, you'll be able to see that effect very clearly. Okay, almost done. Okay, good. So what you can notice here is this gap between the foam and the glass, and here under the foam where the water is, we don't have this effect. So the reason that we have it only here at the top is that the foam is treated as an atmospheric effect inside 3ds Max, whereas the water is just a standard mesh generated by Phoenix. So V-Ray knows how to handle this type of connection between two geometries, but doesn't know how to treat the atmospherics that are colliding with this transparent glass. So what we added in Phoenix is here in the this is the foam shader, and here we introduce this glass correction option. So if I check the glass and again pick the actual glass geometry, and I render again, you can see that I'll have the correct way of this thing, of this connection. But on the other side, I still have some issues here, and you can see that I have some strange interaction here, and the reason for that is again, I have some error gaps as I did here with the water. But since again this is an atmospheric effect, and this gizmo option here in the rendering doesn't know how to fix that, so I can push it a little to help it. So what I did is I scaled the inner faces of the glass just slightly, so that you can imagine that I make manual cutting for the foam only. Okay, so by scaling these faces inwards, my VFB disappeared strangely. Let me just try to find. Okay, here it is. And now by scaling the inner sides of the glass, fixed that issue here. So basically this created a manual cutter for the inside. Okay, and that's it actually. So some of the new things that are coming up to Phoenix I wanted to share with you are these. Actually, I have only some videos to show you. Okay, so this was the beer example. So one of the new features is this morphing. So we can now easily morph liquids and smoke as well. By the way, one of the big updates in the next Phoenix version that is expected to be released this year is the flip solver. So many of the things that I showed you here will change and will be much easier to set up with this new solver. It's a particle-based solver, and it's much more stable, and it's free of grid artifacts that appear in most grid solvers. So this is a feature that we are very, very excited about. We also introduced a new helpers that do very specific things. Let's say this thing, for example, where we have created some splines, and the smoke can follow these splines. Here is the viewport preview of that. So there is a helper object in Phoenix, and you just pick the splines, and the smoke starts following them. It's a really, really cool feature. Another thing is the wave force. So you can now plug the Phoenix FD ocean texture, and in a helper that's called waveforce, and it will start creating real simulation waves. And here is the flip version of the river that I showed you in the beginning. So yeah, if you have any questions regarding the new version or anything else, just I'm here to answer. I don't see any answers in the question bar, but